This is question 65 on chemistry from the 2012 IMAT. So the question tells you to complete the following statements about the first and second electron affinities for oxygen. So they're both either slightly or very endo or exothermic. So firstly, what's meant by the electron affinities? It's the enthalpy change for this process. So the first one is adding one electron to a gaseous atom of oxygen to form the O- ion. Then, so what's the second? That's adding an electron to that to form the 2- ion. And then what does it mean if they're endo or exothermic? Well, firstly, what does it mean to be endothermic? That means it's energetically costly. We have to put energy in for this reaction to happen. And then what about exothermic? That means it's energetically favourable, and this will be a more spontaneous process. So what's the first one going to be? Well, we're adding an electron to an oxygen atom. Do we think this is favourable or costly? Well, oxygen is a very electronegative element, as we know, so it's going to attract an electron and it's going to want to be in the minus charge state. So this is going to be an exothermic process because we know it's favourable. Then will it be slightly or very exothermic? Well, if we think about what we're doing when we're adding this electron, we're going from this 2p4 state, and the electron will pair up with one of these unpaired p electrons to form 2p5, and we know that this will be a slightly unfavourable process because the electrons repel each other, especially when they're paired up in an orbital. So it's not going to be extremely exothermic, it's just going to be slightly because of this countering effect. So that's our first statement complete. And secondly, what about this second electron affinity? Well, so we're adding an electron to something that's already negative. We know that we're going to have to put in a lot of energy for these two to come together, and so it's going to be endothermic. And because they have the same charge, we know this is very unfavourable. They're going to be very endothermic. So this is our final answer. We've completed both statements, and this corresponds to A on the question paper.